Okay, good morning. Welcome to
FamilyMath333a.
Sorry, when I turned the camera on, the camera fell a little bit. There we go. Yeah, 333a. So we're working on a cool problem we saw from Christopher Long on Twitter. And it says, A, B, C, D are positive integers chosen at random. Find the probability that the greatest common divisor of A and B is equal to the greatest common divisor of C and D. We spent about half an hour talking about this yesterday. And where did we get to yesterday?
Well,
So we got to, what's the probability that the GCD of A and B
are relatively prime.
and what's the probability that A and B are relatively prime?
Okay, what would that mean about their greatest common divisor?
The greatest common divisor is 1.
Okay, so the probability that GCD of A and B equals 1 was what?
It was pi, wasn't it 6 over pi?
6 over pi squared.
Ah,
Which one? If it was one of those two, which one would it be? What would that probability
I think it would be 6 over pi squared because 6 over pi would be around 2.
be? Yeah, so we wouldn't want the probability to be 2. So we worked our way up to this yesterday.
Yeah.
That if I pick two integers at random, two positive integers at random, the probability that their greatest common divisor is 1 is 6 over pi squared. It's pretty incredible, actually. Pretty incredible. But so to finish the problem today, we're actually almost done.
Yeah.
But now we have to talk about, we have to take a step back and say, what does it mean to pick two positive integers at random? Why would that be difficult?
Well, because you're picking integers from 1 to infinity inclusive.
Okay.
So you've infinity choices for the first one, infinity choices for the second one, infinity choices for the third one, and infinity choices for the fourth.
Yeah. So what's the problem?
So
It seems like there's like infinity choices.
Yeah. So how do you pick something from out of an infinite number of choices? Not so easy to figure out how you would do that.
yeah.
So one way of thinking about it, and the way I'm sort of been thinking about it on this problem, and in fact the way Chris Long, when he originally posed the problem, said to think about it, is start with a finite set of integers, 1, 2, 3, up to some number n. Maybe n is 10, maybe n is 100.
Yeah.
And then sort of just see what happens as n gets bigger and bigger and bigger. Okay? And so what's the probability, if I go up to n here, what's the probability of picking any integer in this set?
What do you mean of picking?
If I just pick some at random, like if I have up 1, 2, 3 all the way up to n, what's the probability when I pick one integer that I pick 3?
Well, it's 1 out of n.
Yeah, it'd be 1 over n. And then I let n get larger and larger and just kind of see what happens.
Yeah.
Alright. But this comes into play in a couple different ways of what we were talking about yesterday and what we're going to be talking about a little bit today. How many integers here are divisible by 2?
Well,
Half of them.
well, maybe not half of them.
Okay, why
'Cause there
might
could
it,
be half of them or one less than half of them.
do you see why? Do you see why it might be 1 less than a half?
Well, n could be, well, but n could be odd.
Yeah, n could be odd, so it might be 1 less than a half.
Yeah.
Alright, so for example, if the set was just 1, 2, 3, well there's only one even number
And 2 odd.
and 2 odds. Now, that difference is important here when I have 1, 2, and 3, but as I get bigger and bigger, what happens to that distinction?
Well, it gets smaller and smaller. It's
Yeah.
it's getting closer and closer to a half and a half.
Yeah, and then how many integers are divisible by 3?
Well,
Well, a third of them are divisible by. You mean in the set of n?
Yeah, up to n.
Well-
but not 1/3 of them. There's
Well, there could be a third of them.
Might be a third. When would it be exactly a third?
If n is a multiple of 3.
Yeah, n's a multiple of 3.
some multiple. It's
But it might be slightly less than a third
hmm,
in other situations.
So it could be 1 less or 2 less than a multiple of 3.
Yeah, and does that matter as n gets bigger and bigger?
Not really.
Not really.
Matters less than
So
less.
it's pretty close to a third, and the other one was pretty close to a half.
So we're making some just subtle assumptions, and then we're kind of washing a few things under the rug. But this is what happens. This is how we're thinking about picking numbers from an infinite set. Start with a finite set and let it grow larger and larger and larger.
yeah.
And then eventually, when it's infinitely big, we sort of approach for the two numbers being relatively prime. we approach 6 over pi squared, which was about 0.6.
Yeah.
Right?
Yep.
Okay. All right, let's move on to part B.
Okay.